this is Mr. Royks, and we're going to look at this limiting reactant problem here. The question asks, magnesium nitride can be formed from a reaction of magnesium metal with nitrogen gas. How many grams of magnesium nitride can be made from the reaction of 35 grams of magnesium and 15 grams of nitrogen? And the follow-up question to that is, how many grams of the excess reactant remains after the reaction? So this is a multi-part question. The very first part we're going to need to do is we're going to need to come up with the balanced chemical equation. So here's the chemical equation. We have magnesium metal reacting with nitrogen gas to form magnesium nitride. Again, the magnesium nitride is coming from the positive 2 charge on the magnesium going to the nitrogen, and the nitrogen with the negative 3 charge, the 3 going to the magnesium. And then to balance this, all we actually need is a 3 in front of the first magnesium. So now we have it balanced. Let's look at the problem. If we start with 35 grams of magnesium, the first thing we want to do is we want to go to moles of magnesium. So we say that 1 mole is 24 grams. Next thing that we want to do is we want to look at the mole ratio, and there are 3 moles of magnesium per 1 mole of magnesium nitride. Now we have it in moles of magnesium nitride. We want to figure out how many grams of magnesium nitride form. So we have 1 mole of the Mg3, and 2 has a molar mass of approximately 100 grams. And out of this we get 48.6 grams of the Mg3N2. So then we need to look at how many grams of Mg3N2 we can get out of the nitrogen. So we'll set that problem up. Okay, and there's a setup for that problem where we have grams of nitrogen converted to moles of nitrogen, then converted to moles of Mg3N2, and then finally converted to grams of Mg3N2. And the mass we get there is 53.57 grams. So again, the limiting reactant is the one that produces the lesser amount of our of our product, and obviously 48.6 is smaller than 53.57, so the limiting reactant is going to be the 35 grams of magnesium. So that's how you do the first part of the question. The second part of the question is what you can do is based on the formation of 48.6 grams, based on the formation of 48.6 grams, we can come up with how much of our nitrogen, our mass of nitrogen, would we actually use. And there's the setup for the second part of the equation, where we are solving for grams of nitrogen. So we end up using 13.1 grams of nitrogen, and then lastly 15 grams of nitrogen minus 13.1 gives us an answer of 1.9 grams. That's it.